Hello everybody, I will start my today with another coding practice. So this is a video which follows up my previous video about odd even jump question. So in my previous video, I solved this question with top-down dynamic programming and sorted set. And in this video, I will introduce another solution which uses top-down dynamic programming and monotonic stack. Yeah. So let me get started. Firstly, I will quickly review the question statement. So in this question, I'm given an integer array, and I can start from any position. Then my goal is to reach the last index. Yeah. And for that, I start from somewhere, and in the odd number jumps, so for the first jump, third jump, I can jump to the cell which is on the right hand side and also larger than the current number, but smallest one out of these numbers. So for example, if I'm at 13 here in line 4, I can jump to okay, I will take a look at the right hand side numbers, and out of these three numbers, there's numbers which is 13 or larger is 14 or 15. Out of these, I can jump to the smallest number, so 14 is the next destination. So this is the odd number jump. And for even number jumps, for example, after reaching to say 14, oh no, just forget it. So I will think from 13. Yeah. For the even number, I will jump to the right hand side and also number which is smaller than the current number 13 or equal. And out of these, I jump to the largest number. So in this case, let me add one more number like this. When I'm at 13, I will take a look at the right-hand smaller or equal number, which is 12 or 10. And out of these numbers, I jump to the largest one, which is 12. So 12 is the next destination. So that's the even number jump. Okay, so this is a question statement. So based on these jumps, I start from anywhere and I try to reach the last index. And my task is to return the number of such starts, which I can reach to the last index in the end. Okay, so basically in my previous video, I used the dynamic programming like this. Yeah, if good means I can reach to the end. Tail, yeah. So basically from each index, where the next jump is odd or even, these states of each, step. Each step can be represented by this, and based on this, I can in line 38, I can see I will think of the next destination and recursively think if the next destination is good or not. So that's the basic idea. And in line 48, I guess the next index. So from each index and also whether it is the next jump is odd or even, I try to guess the destination of the jump. And to build this, actually, so next index is a hash map in this implementation. And to implement this hash map, I used the sorted set. Yeah. And sorted part set takes log n time or n log n time. And dynamic programming part takes O of n time. And in total, it takes n log n time. However, actually, there is another solution. approach to build the next index's hash map. So aside from that, the solution I will introduce from now is the same. I will use the top-down dynamic programming, but the difference is that I use the monotonic stack to build next index's hash map. Okay, so that being said, let me get started. I quickly update this to build next indexes. Okay, and so in this video, my task is to implement this method. Okay. So let me think. If the given array is like this, so because I'd like to know the, next number, number which is next greater number, which is on the right hand side. Yeah. So to find that number, I will use the sorting, but with index in the same tuple. Firstly, I will build this list of tuple. Like this. Then oh, wait. Okay, so from here, I will build list of tuples. Then, what should I do? I will sort this. So now it looks like this. Yeah. Then from here, what I would do is take a look at each number, and then what I can find is, so from here, for example, 10, I try to find the larger number. So in the case of, okay, I will think of the case of the odd number jump. Yeah. In that case, from 10, I try to jump to 12 or 13 or 14 or 15. Out of these, I will find the index, which is, larger than 0 because I jump to the right hand side. And also in those, I find the youngest index. There should be now 2. Okay, so sorry. So firstly, because I'm here and index is 0, I will filter the possible options with index is 1 or more later. Then I filter it with number which is larger than 10, so all remains. Then I find the smallest number out of this, so it should be this, 12.2. But if there is, say, 12.3 or 12.4, in that case, I jump to index 2 because I have to find the youngest index. Yeah, out of the same numbers. So that's it. Okay. And when I go to number 12, I can find that I'd like to jump to index 3 or later. So, okay. And the thing is, the resource is already sorted. So it is guaranteed that next element is the next greater number. However, it can be on the left hand side of the current number. So I have to take care of it. Otherwise, so I can say from the current number, I will traverse the list, and if I find the number whose index is larger, then immediately just the, jump destination. Okay, good. So I actually don't, yeah, I can completely forget this, number in the first element. Again, so I will start from somewhere. Then I will find the index which is equal or larger. So what I want to do is find the next greater element number in the right hand side. That's what I'd like to do. Okay, so that being said, for example, if I can find the larger number, then immediately the destination is determined like this. So if I'm at 2, and if the number is, the next one is index 2, which is larger than 0, so 0, 2 is immediately determined. However, when I move to 2, I found that 1 is not larger than, 2. So it doesn't work. But 3, this is larger than 2, so this works. And also this is larger than 1. So in this case, I just use the stack. I will call it monotonic stack. No, decreasing stack. And I put 2 first, then 1. And now 3 arrives, and this cancels this and this. And then 3 is included instead of them as the first element. Then after that, this comes 4. Yeah. So 4 is larger than 3. So, 3 to 4 is possible. So that's what I can say from this. Okay. So, because I have to completely separate odd number jumps and even number jumps, I update the index. Okay, so update all the next jumps indexes and even next indexes. Okay. Oh, no. I don't need it here. Wait, what I'm doing. Okay, so next index is hash map. So as I said, first thing is Okay, I built the num and index tuple, and then I sort it. Okay, now what I will get is something like this. Then from here, as I said, I don't have to take care of the first element. I will just take a look at the second element, only index. Wait, this should be monotonically decreasing. And if same number can be chosen, monotonically and trajectory decreasing. Okay, so that being said, okay, so for each index, I will take a look at stack. The last one is smaller or equal to the current index. Then I will pop it. So this is the previous index, which means that it can jump to index I. So yeah, I append this. Then I continue. So once length of substack is 0 or the new number is smaller than head number, like this state, I will continue. Okay. Yeah, so that's how basically how it works. Okay. And for I will do the similar thing in update even next index. So for even indexes, the jump destination should be the number smaller but largest. Smaller than or equal but largest. So basically, I will do similar. I'd like to decrease so the number decreasing. But I will make a slight difference. So I will multiply negative here. In this way, the numbers are moving, sorted in larger to smaller order. So for example, in this case, I append negative to head. The first element. Then I sort it in ascending order. So now it becomes like this. No, this. Okay, so now it works like this. And then what I should do is start from some index and then find the, I mean, smaller number, but largest number. So when I take a look at this, obviously 14 is the smaller but the largest out of 14, 13, 12, 10. This is good. So I continue. And when I'm at 14, all the numbers greater than 14 is actually smaller and sorted in descending order. So I should pick the one which is as early as possible. However, with this one, index is 1, which is on the left hand side of 3, I can choose this. And for 12, and same for 10. But if I can choose it, I will choose it. Okay, so basically, I will take a look at the index. Okay, then from number 4, I find the larger index which doesn't exist. Yeah. So when it doesn't exist, I just put it in the heap, not stack. And then when I get 3, yes, 3 is smaller than 4. So this means that 4 has found the destination to 3. Yeah. Which is good. Then the next element, number 1, is pushed into. Then when 1 is pushed into, 3 is resolved with 1. Then, so now there's only 1 here. Then next 3, 2 is appended, 2 appears, but 2 doesn't resolve anything. So now stack is 1 and 2. Yep. Then I get 0, and actually 0 resolves anything because 2 can jump to 0. Index. No, what am I doing? So when index 2 is coming, I can jump to 2. No, I have to go down. Oh, so no, I cannot. Okay. But when I get 0, no, I cannot. Wait. So when I get 4 and then 3, this is the index. So 4 to 3 jump is not possible. 4 to 1 jump is also not possible. But yeah. When index 2 is appears, this is made it possible to jump from 1 to 2, and now 1 is deleted. Good. Then I get the last index 0. So who can jump to 0? Nothing. So when I take a look 2 and 0, I can't find it. It's still here. Okay, so that being said, I can say this is monotonically decreasing trajectory. Yep, decreasing. Good. Okay, so Remister's implementation, just like update all the next indexes. Oh, I think simply I just copy pasted it. Okay. So this is good, and I sold it. And stack should be monotonically strictly decreasing. Yes. Wait, what I'm doing? Ah, I see. This is same because basically after the number is sorted, Then I have to find the index, which is on the right hand side of the current number, current index. So basic idea is the same, aside from this sorting in rank 103. Okay, good. That being said, let me execute my code. Hmm. Syntax is invalid. Okay. Okay, so let me take a look. So the first thing I'd like to do is I will take a look at the next indexes array. Oh wait, I forgot something. So when I'm at here in line 186, this is okay. Oh, and here in line 122, this should be false because I was talking about the, even next jump. Okay. Here, this, hash map is empty. Let me check. Oh, I've completely forgot something. I have to append the new element into the stack. So which one is index I? Okay. I run my code again. Hmm. But still, it seems like, next index is empty. Yeah, I think this is correct. But this is not updated in here, which is a bit weird. And in this part, yep, I think this is good. Yeah. Let me print how stack is like. I see. So even though I put in something, stack is doesn't go bigger. Okay, I see. So I have to stack append at here. After while loop, indentation was wrong. Okay, good, accepted. So I remove the print statement and I submit my code. Good, okay. So let me quickly wrap up my today's second video on this odd even jump question. Oh, but before that, I will do the complex analysis. So for complex analysis, time complexity is completely the same because in the update all the next indexes method in line 79, I did the sorting. So sorting takes n log n time, and aside from that, in line 83, what I'm doing is just iterating the number to be pushed, and also in line 84, maybe some numbers may be pushed, popped out, but each number is popped out exactly once, which means that the time complexity should be O of n for pushing and O of n for popping. This should be O of n. Okay. And for space complexity, I use the num and indexes array or something or stack. All of them, the ranks are up to n, so it should be O of n. Okay. And for the recursion stack, it can have up to n stack and the recursion codes in a row. So it should be O of n. In total, it should be O of n. Okay, good. So let me quickly wrap up on said coding practice. So this was my second video on this question or the even jump. And in my previous video, I solved this question with top-down dynamic programming and solved this set to build the hash map from current index and next is even not flag to the destination index. However, in this video, I use another approach to build the hash map of the destination. The rest, I use a monotonic stack. Yeah. So I sort the numbers by the number. So now it's ascending order, and out of this, okay. So the next, I just say next greater number is exactly the number which is just after the current index. However, in some cases, that next index is actually before the current index. In that case, I cannot jump to that index, so I will skip it. And in that way, I can decide the next destination for each index. And in that process, if I cannot find the next destination immediately, I push them into the stack. And and the interesting is that this stack element is strictly decreasing. Yeah. So this is a monotonic stack. And with that, I can, here's the hash map. And this is the same in update even next indexes method too. Okay, so based on this, I built the current index and next is jumper. Next is not old numbered boolean. I mean, from these tuppers, I can find the next destination. I mean, I can build such a hash map in n log n time. So combining this hash map and top-down dynamic programming, the time complexity should be O of n log n. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.